Okay, for now, let's get more derivation examples to get familiarized with the derivative equations and how to apply those in a real-life examples as moving forward in your career with the calculus. Here we have an example on the power rule. We have y equal x to the power of minus 3. Now, as you remember, in the power rule, if you have x to the power of n, deriving that will give you n multiplied by x to the power of n minus 1. Here you have x to the power of minus 3. What is the derivative for that? If we take y prime, that gives you minus 3 multiplied by x to the power of minus 3 minus 1, and this will give you minus 3 multiplied by x to the power of minus 4, and that's your final solution in this case. Let's move on with a different example. We have a little scary example. We have x to the power 4, the third root of x to the power 4. How are we gonna solve that? It is a power rule application still, even though it looks different. So you have f of x equals the cubic root of x to the power of 4. We can give it a different representation to make it less scary. We can say f of x equals x to the power of 4 over 3. How did we get that? We know that the cubic root of x can be written as x to the power of 1 over 3. The power of what's inside the root on the power of the root degree. So 1 over 3. Now in this case, we have x to the power of 4 and we have the root of 3, or the cubic root in this case. So x to the power of 4 over 3 is the same representation of the cubic root of x to the power of 4. So we can see here x to the power of 4 over 3. Now it's clear now. So it is clear now that you have a power problem. Finding the derivative of that representation give you same rule, the power of x to the power of n. N here is 4 over 3. So we say 4 over 3 multiplied by x to the power of 4 over 3 minus 1. 1 can be represented as 3 over 3. So you have 4 over 3 multiplied by x to the power of 4 over 3 minus 3 over 3, which is 1. But you need to have the same denominator to be able to do the addition or subtraction in this case. So you need to have the same denominator to do the addition or subtraction in this case for the power. So your final solution will be 4 over 3 multiplied by x to the power of 1 over 3. And that's exactly the final answer for you. Let's move on. You have f of x equals x to the power of 5 plus 5x squared. This is a power problem as well. So finding the f prime of x equals, now x to the power of 5, that's 5 multiplied by x to the power of 5 minus 1, which is 4, plus we apply the power rule for the next one because we have addition and subtraction. If we have a multiplication or division, we need to follow that specific rule for multiplication and division derivatives. But in this case, you can distribute the derivative on the addition or subtraction of your expression. Okay, the other part we have 5x squared. Now 5, keep it on the side, it's a constant, multiplied by 2 multiplied by x to the power of 2 minus 1, which is 1. Your final answer would be 5x to the power of 4 plus 10x. Let's move on to the next one. You have this expression and you need to find the derivative for that function. F prime of x, as you see, this is a power rule application. You can distribute the derivative on the addition and subtraction of the expression, and you can take the derivative of each part of that expression on the side and put them all together. In this case, x to the power of 3, that's derivative of that is 3 multiplied by x to the power of 3 minus 2, or of 3 minus 1, which is 2. Then we have minus 6 as a constant, keep it there, multiplied by x squared. Derivative would be 2x. Keep that in parentheses so that you keep track of things. You have minus 5 multiplied by x, that's minus 5. Because x to the power of 1, then 1 minus 1 would be 0, x to the power of 0 would be 1. So it will vanish. And 3 is a constant, so will be eliminated with the derivative. So your final simplified solution for this expression derivative would be 3x squared minus 12x minus 5. And that would be your final answer.